Language is defined by common use. So also, if you get people to change a word, it just becomes changed.
Reaction rate is... Wait,
It's like from changing hello to hi.
Riz is definitely going to be in the dictionary in the next like 50 years. 100%. High 10%.
Do you know why we say okay? What it stands for?
It's probably some Latin thing.
No,
It stands for all correct.
Yeah.
Oh, all correct.
But they said all correct with an O and a K as a meme, and it just caught on. Because they thought it was funny to purposely misspell things.
Is that an American thing? Like,
No, it's like an English meme pamphlet thing.
Vox did a video about it.
Oh.
Do you know Mr.
No, I've heard of it. I think I've watched a few.
They're good.
Yeah.
I really like them.
You know what's also really good advice? But they've fallen off in the past few years. But they used to be really good back in like 2011. And after like 2017, they become like kind of annoying.
They were bought out.
Sorry. Oh yeah, bought out, yeah.
Yeah. You don't have to apologize for it.
No, I thought
It's
you
not
were
your fault.
to do chemistry. I was like, oh.
Yeah, you probably should. I probably should do that. Okay, now that we're finally up and going, the live stream is on. You can put away your Hebden, and on your sheet of paper, start doing this problem. I will ask someone for the solution in a moment. Why do we have that? There we go. So there we go. Yeah.
will we be able to see our test?
Yes. Eventually. But not today. Oh, and speaking of your Chemistry 11 quizzes / tests, they count until they don't. So they will count, Dylan? They will count for right now. As soon as you do your first major Chemistry 12 test, and I can replace a real Chemistry 12 mark with that mark, then I will discount them if it is in your favor. And so they will go away as you do better in Chemistry 12. But they're just sort of a starting point. They count for the moment because I just put them in for the moment, but they are intended once we've done our first major unit test to go away. So they're basically all quizzes become formative in this class once you write a major test on it. Yeah.
Do we get to see them or no?
Yeah, you will get to see them.
At the end of the class?
And you'll not today. You will get a folder, and you're going to put it into the folder. Pardon? Yeah, you still have to write it. And one of the things that was next with, all those waiting to see it, until the people who haven't written it have written it, well, none of us will get to see it. Curse Dylan. Okay. Oh, where's the... There it is. I will ask someone at random using Class Dojo to do this problem. Class Dojo. Out. There. Random. Okay. Felix, where are you? How do you do how if the amount of A decreases by 2.10 times 10 to the minus 5 moles per second, why don't we say the first one is the rate of B? How do we calculate the rate of B?
Wouldn't you just divide it by the same like ratio?
Yeah, but how? What are the numbers? What ratio?
What's it, 2 to 1 to 3 to 1 ratio?
So what fraction would I multiply by?
You divide it for B, you divide it by half.
You would divide it by a half.
Oh, no, you multiply it by half.
Multiply by a half, yeah. So what you're going to 1 over 2 because that's 1, and you're at a, so that's 2. So you're always going to divide it by 2. And what number did you get for that?
I haven't done it yet.
Oh, do that.
Let me get my calculator.
And then while you're doing that, I'm going to ask someone else for the rate of B. Sorry, part B, which is going to be the rate of C. And that shall be loose. How do I calculate it for C? If it's A, what would I divide by? Divide by 2. And if I'm going to C, what would I multiply by? Times by 3. Excellent. 3C over 2A. And do you have a number for that? Felix, do you have yours? No, I've asked specific people. This is also checking if they can use their calculators. Felix, do you have a calculator?
Yeah, I just didn't bring in my bag.
Okay. In the future, as a warning for everybody, we'll call it Felix's rule. You must bring a calculator to each and every class. Get it, write your name on it, bedazzle it. Luce, do you have yours? Oh, hold it. Yes?
1.05 times 10 to the power of negative 5.
Yep, what are the units?
Mole per second.
Moles per second. Thank you, Felix. Luce? 3.15 Yeah. And then moles per second. So stoichiometry works for rate in addition to moles. And so if you have a rate of 1, you can use stoichiometry to get to any other piece. Your book goes into this into a little bit more detail in the practice problems because, of course, now you can use all your Chemistry 11 information. You can convert the moles to grams. Now, if you had a rate in grams per second, would you be able to use stoichiometry to move that around?
Yeah. If you just figure out the moles.
Say that really loud.
You just figure out the moles.
I feel like you said yes, but then no. Because yes, as long as you don't use it and convert it to moles.
Yeah.
Yeah. So if it's in pure grams, you got to convert it to moles first. Perfect. That's coming up. Methods of monitoring a reaction rate. If we wanted to, now we had one last day. What ways could we use to monitor a reaction rate? What did we use last day? Chemistry. What were we measuring when we had the little table there? Yeah? It was the mass. So I think that's way down here, 5. A mass change. And that only tends to be useful when we actually have a gas leaving, so you need an open system. So reaction rate is equal to the change in mass over the change in time. Here's more heading. For all of these that we're going to do, you would plot a graph and you'd use the slope, as we mentioned, to calculate the rate. That's also going to be in the lab. So what do you use a spectrophotometer for?
No idea.
Okay, so that's new. Okay. What would you use a thermometer for? Temperature. So you can have a temperature change. If you have a reaction A plus B goes to C plus 70 kilojoules, it will consistently give off an amount of heat. You can measure the change in temperature as a proxy for the change in substance, because it is also giving out energy in proportion to the amount of stuff. So reaction rate equals the change in temp. 70 kilojoules. And we already went through what delta means. What does delta mean? Change in. And what minus what?
Initial minus final. Oh, sorry, final minus initial.
Final minus initial. Excellent. I feel like this one might be a little obvious. What does a pressure gauge measure? Pressure change. So if we don't have an open system with the Alka-Seltzer thing and I capped it off, evolving the gas, it wouldn't change in mass, but it would change in pressure. And you can measure the change in pressure as a proxy then for the change in concentration. So the reaction rate is the change in pressure over the change in time. And a reminder, every time we write this, change in pressure over change in time, we mean P final minus P initial over T final minus T initial. What must the temperature be in? I'm hearing Kelvin.
Oh, is that pressure over
Pressure.
Time?
Oh, I made it over temperature because I just did temperature above. That should be time.
Oh, okay.
Yeah,
Not measuring time in Kelvin.
yeah.
what's a Kelvin?
A Kelvin is a properly scored temperature. Who asked what is a Kelvin? Is a properly scored temperature scale. So both Celsius and Fahrenheit are kind of mixed up because they have a zero. But do you have zero energy at zero? No, because there's still some heat there. They're just cold to our touch. Now, Celsius was based at 0 is when water freezes, and 100 is when water boils. And because water is so ubiquitous in both the kitchen and the lab, that's pretty useful. Most of the world uses Celsius units. Some countries use freedom units, otherwise known as Fahrenheit. And they made the Fahrenheit 0 is the coldest temperature they could make in the lab at the time. And then the 100 is what felt hot. I mean, it's no more arbitrary than what the Celsius was. I shouldn't make fun of Fahrenheit. And Canadians, of course, are weird because we use pounds for weight and grams in the grocery store and kilometers on the road, but miles when we're talking about really far distance. Canadians don't know what they're doing. But if you want to make 0 actually 0, then you make 0 absolute 0, 0 energy.
Isn't Kelvin just
1 second, because far too many people start whispering talking. So 0 Kelvin is negative 273.16 Celsius. It is a Celsius scale in the sense that a change in degree of 1 degree Kelvin is the same as the change of degree in 1 degree Celsius. So the degrees jump by the same amount. And so 0 in Kelvin, 0 Celsius in Kelvin is 273 Kelvin. But it puts a 0 in the proper place, so you don't get weird negatives and positives when you minus and subtract and all that kind of things. And when you multiply, every temperature is positive because every temperature has an energy except for 0.
How does it relate to time?
It doesn't. I accidentally put big T for temperature because I was silly. Yes, Nicholas.
do we use PSI or pressure?
Oh, you use kilopascals. The System International unit. So pounds per square inch is a freedom unit. What's the other one you said? Bar, I think, is based on millimeters of mercury and is also an old unit. You'll still see both of them being used. If you look up, Canada's weather report, you'll find it's in kilopascals for the temperature. Labs will use whatever they have instruments for. Yes.
So
Atmosphere is an old measurement. It's intended to be the pressure of one atmosphere at sea level. It is roughly equivalent to 100 kilopascals. Yes.
Isn't it hectopascals?
Sorry, what?
Isn't it hectopascals?
Hectopascals?
Hectopascal, like HPA?
Oh, sure. I mean, I think maybe deca? I haven't heard of hecka. That's a heck of a pascal. Hecto?
Yeah.
I haven't heard of that.
Here,
But, no, we don't need to because we're going to move on. We're not going to use it in class.
Oh.
But if it's part of the unitary system and it stands for a certain number, sure. You could put kilo, milli, mega, whatever you want in front of a pascal. Pascal's the unit. Okay. Next up, recognize some factors that control reaction rates. Now I have...
What about the first one? Yeah, what about the first one?
Oh, right. You don't know what a spectrophotometer is. Maybe you don't deserve to know. Well, no, there were some guesses at the back. Absolutely, it's light. But this is used for color change.
Oh, that's yes, thank you. During some what?
Reactions.
How are you more American?
You're the one who's like cheering on Fahrenheit. Definitely not.
Gentlemen, I can hear you from here. You're not whispering, and it makes it very distracting.
It's hard to...
Dylan,
Yes.
do you need to move up one?
I'll quiet.
At which a reaction.
Car? No, can't.
Car and...
During some reactions, color changes can indicate the speed at which a reaction is occurring. If one of your products has a color component, or one of your reactants does and it disappears, so either how quickly it disappears or how quickly it appears. Really handy when you can do, you shine a beam of light in it through it, and then when that beam of light is interrupted by the color, that tells you how much is present, and you can get standardized solutions of different concentrations, standardize the machine, and then use color change for an indication of the concentration. I am going to get rid of that word light there because I want to write more.
Why is color supposed to be good at the top and the lower?
Because I mentioned Fahrenheit before, so I thought I'd switch to freedom spellings.
That makes sense.
Yeah. Although it is spelled incorrectly, if you are ESL and you spell color without a U, we will still accept you in this class.
Wait, that's a good It's just correct. Honestly.
Well, there's people who speak English and people who speak American. True. Okay, next up. What time is the class? Yeah, 11:10. Got everybody? Okay. Recognize some factors that control rates. I have some demos for this for next day. Given the shortness of this block, we're going to write the notes now, and I'll get the demos out next day. If I don't, you're allowed to hey, you said we could have demos. So we're going to talk first about if you wanted to increase the rate of reaction, what is the first thing you would do?
Add more
energy.
More energy. How would you add more energy?
More products.
More products won't make it go faster.
More
Yep.
reactants.
Heat it up. Put it on the stove. Get it really hot. Temperature makes everything go faster, including grade 9s. Why does increasing the temperature increase the rate of reaction? Yes.
Because as the molecules have more energy, they're moving around and have more energy and are able to overcome the reaction rate.
They have more energy. So if they have more energy, how are they moving?
Faster.
Faster. So if they're moving faster, that means you get more collisions, and those collisions have more energy, which we'll look at later in terms of reaction intermediates. Because a reaction is just a collision. So if you increase the number of collisions, you just increase your chance of a reaction. And so if you do all these things, then the reaction rate.
Time decreases.
Yep, time decreases. If you ever go or you've been scammed into paying money for one of those dating books that are endlessly advertised online, you'll find that their main method is just to convince you to dress weird and then, key part, ask people out all the time. Most people will turn you down, but if you only ask people once every few months, but if you ask 100 people a night whenever you go out, somebody will be foolish enough to say yes. You just increase your collision rate and you increase the number of reaction rates. Life advice. Don't spend money on the books because they also will convince you to dress weird and give you a nice dose of toxicity at the same time. The other way, increase the concentration. So you want to increase your collision rate. You could ask more people out, but also you've got to find more people. If you ask everybody in this classroom, you're done. Where else could you ask?
The next classroom.
You can move from classroom to classroom, or at assembly, get everybody in the same room. Just start going through them by row.
Go up on stage.
Just go up on stage.
Who wants to go out with
Yeah.
this guy?
Now that you've said that, that did happen once. Someone didn't have a snowball date,
That's so sad.
and the prefects did it for them.
Oh, that's
It was kind of cute. Yeah. And then there was a volunteer, like, I'll take you. Yeah. Yeah. Anyway, concentration. If you increase the concentration, if I do that, does everybody know what I mean?
Nope.
What is
Language.
another language? What does
Sure you're like drawing it right.
what does this mean?
Oh, no.
That doesn't mean no. Anything inside a bracket. Bracket means concentration. If I go concentration Na plus, I mean concentration of Na plus. And that way we can quickly write concentration of Na plus is equal to 1.3 moles per liter. It's a shorthand for chemists. So when I write square brackets, I just mean the word concentration. What does an arrow up mean? Increases. So concentration increases. And then if the concentration increase, what else increases?
Collisions increase.
Collisions increase. And then what happens to the amount of time between successful collisions? Decreases. Also, we didn't write this down, but I should highlight it. Every time you increase the temperature by about 10 degrees Celsius, which is roughly 20 degrees Fahrenheit, you will double the reaction rate. So this is why if you're cooking and something's supposed to take place at 350 degrees and you're like, I need it to go twice as fast, so I'll put it at 700 degrees. That's not how it works. It will go twice as fast if you just take it from 350 Fahrenheit to about 370 Fahrenheit. Now that being said, temperature takes time to move into the food. It probably has some thickness. There's some diffusion rates that occur with that, and so it's not a perfect science. But the food on the outside will definitely do that twice as fast. T, lowercase t, is time.
Oh, so that's time?
That's time.
Oh.
And we get more collisions because we have more atoms per centimeter. Is centimeters squared there correct?
Centimeters cubed.
Centimeters cubed.
I'm so smart.
See? Pressure. I'm going to draw a box to demonstrate this, and then I want you to explain it. So let's say I've got that, and then I've got that. We'll say that this box is 2.0 liters, and to make this work, I'll say this is 0.5 liters, and I'm also going to put in, nope, let's go creative pen. Let's do some smiley faces. So there's our little reactants. I didn't increase the concentration. Why will these react more slowly than these?
Further apart.
Further apart.
Concentration.
So it just takes more time for them to go across. And somebody said the word concentration. When you're dealing with pressure, having a smaller volume is the same as increasing the concentration. So if I was to do the concentration for this one, we have 4 atoms per 2 liters. What's my concentration?
8 atoms per liter.
4 divided by 2?
Oh, no, my bad. 2 atoms per liter.
2 atoms per liter. And it's already done here. If we have 4 atoms in a smaller space, now we have a concentration of 8 atoms per liter. The concentration went up even though we didn't increase the amount of stuff in there. All we did was decrease the volume, and they will react much, much faster. Yeah.
What's the difference between like B and C?
This, for pressure, we're dealing with a gas. And pressure functions as concentration for a gas. For B, when we're talking about concentration, we're talking about a liquid. So we're talking about like 1.0 molar NaOH or 5.0 molar NaOH. In these two cases, you may have the same volume of both, but which will react faster?
The first one.
The first one will react faster?
Oh no, sorry, the second one.
Second one.
Fifth one.
Yeah. And I do have a demo for this next day. We're going to watch some zinc react with hydrochloric acid at a couple of concentrations. I don't want to get it all out right now in a shortened block. But we'll show these ones as well. Yes, Nicholas.
Doesn't surface area also play a role?
Surface area does play a role, but only for one type of thing. What type of thing?
Solids.
Solids, yeah. Solids because you can grind them up. But you can't grind a liquid up. It's already at maximum surface area.
What about catalysts?
Catalysts will greatly increase the rate of reaction.
Decrease activation energy.
Yeah. We don't do activation quite yet, but were you in AP last year?
Yes.
Aha. So you've already done this.
Yeah.
Yeah, I'm not going to call on you anymore. Now my favorite one is D.
Oh my god. Sorry. That was scary.
Nature of reactants. And this one says, some things go faster because they're faster.
Nice.
Yeah.
I like that one.
You take a couple of people, you put them on a field, and you say run, and you've fed them both the same thing. They've both had the same amount of steroids, same amount of training. But some people will just be faster. Boom.
That's me.
And that's just because a whole host of things are just different about them. I remember going to a conference. It was for boarding schools. I went with the IT person and a coach. And while I was there, the coach was talking to a coach of a university who was like scouting for people and coaches on the universities to get people to come to his university for rowing. And this girl runs up to him and is like, hey, I hear you from this. I really want to go to university. I've won this at my high school. Here's my card. I'd love to go if we can talk. We'll do rowing. He goes, yeah, I think we'd love to have you. Just set something up with the office. Gives her a number. She walks away. He takes her card and throws it in the trash. And I'm like, that seems harsh. Why'd you do that? He says, wrong leg ratios. Just by looking at the bone structure, he could tell they'll never be Olympic level rower. And he's looking for Olympic level rowers. And Olympic level rowers, you have to have dedication, hard work, and the right genetics. And if you don't have that, you're not going to be Olympic level because it's about leverage. It's a different sport. It's the nature of some reactants to react faster than others. And at that, you can't fix that. Although my friend David, now that I think, never thought of this before, when he was about your age, his parents came to him and said, would you like to be taller? He was like, what? Well, they had researched a procedure in which they break your legs and then they stretch it and then the bone grows and you can do that. You get like an extra inch. David, until this time, had never thought of himself as short. He was a little short. It was like, I don't know, 5'4", 5'5", but he had never had any issue with it. He didn't realize his parents thought he was too short and didn't love him until that moment. Aha! My stories took me out. I should have gone faster. We'll have some demos next day. Finish it off. You got a little bit more Hebden.